Graphing cosecant and secant functions. Okay, so now we're going to try drawing some of these things by hand. It's not too bad. Our strategy is we'll just graph the corresponding sine or cosine function, and then all we have to do is add in the asymptotes and the u's, and we're all set. We've got y equals -3 cosecant of pi x plus 1. We're not going to graph that cosecant function at the first. We are going to graph the corresponding reciprocal function, which of course would just be y equals -3 sine of pi x plus 1. Let's concentrate on that. Basic starting shape, this is reflected sine, the valley and the hill. Amplitude is clearly 3. Period would be 2 pi divided by the b number, the pi, which of course is going to reduce to 2. The midline is at y equals 1, the d number. Coordinates of 5 key points. Well, I have starting at 0, ending at 2, cut it in half, cut it in half. I'm counting by halves here, so 0, 1/2, 1, it would be 1.5, which is 3 halves, and then 2. Notice the instructions for the graph. We're first going to show the corresponding sine or cosine graph, in this case a sine graph. We'll do that dashed because that's not really the final picture. Then we'll put on the final graph of this cosecant function. So let's add on our scale. Let's see, on the y-axis, my midline's at 1. I'm going to have to go 3 higher because of the amplitude, and 3 lower. What would that be, -2? I'll draw in the midline, and then I'm ready to mark on my 5 key points. Let's see, reflected sine starts at the middle, then moves on to the low. The low would be -2, then back to the middle, then to the high. The high would be 4, 3 units above the midline, and then back to the middle. So here's my valley and hill shape. I'm going to make it dashed because this isn't really the final answer. Okay, now we can easily draw on the cosecant function. Every hill gets an upward u. Every valley gets a downward u. Where do the asymptotes go? The asymptotes happen at the midline spots. And so for us, that would mean an asymptote here, an asymptote at 1, an asymptote at 2, at all those midline spots. Then add on the u shapes. I've got a downward U there, I've got an upward U here. The U shapes connect to the corresponding sine or cosine shape at the highest and lowest spots there. And that's it. I've drawn my graph for one period. As you can see, it's very similar to what we've already done. Okay, we want to write down the equations of all the asymptotes. Let me do that off to the side here. Remember, we learned how to do this. All we have to do is find the easiest starting asymptote. Well, that's obviously the one at 0, at x equals 0, and then add to it multiples of the distance between every asymptote. Well, I have 0 to 1, and then I have 1 to 2. Obviously, the distance between is just 1. Well, this simplifies a lot. The 0 doesn't matter, and k times 1 is just k. Here is the equation of every single vertical asymptote, x equals k, where k is an integer. Lastly, how about the range? Well, once again, I think I'm going to have to do it in 2 pieces. It looks like I've got numbers from -infinity all the way up to -2 in that bottom u section. Union, the upper u section starts at 4, is the lowest y value, and then of course goes up to infinity. Here would be the range of my function. Okay, let's try another one. So now I've got y equals 2 secant of 1/2 x plus pi over 2. Well, we're not going to graph the secant function first. We're going to graph the corresponding cosine function. Now notice as I'm writing it down, there is a reminder here that I do need to change this to that factored form. So I want to graph the corresponding cosine, but right now it's not quite in the right format. I'm going to have to factor that b number to the front so that I can clearly see the phase shift. Let's see, obviously this will be an x. This will be a plus. What number do I put there? Remember, factoring is essentially like dividing. I'm just taking that pi over 2 and dividing it by 1/2. That's the same thing as multiplying by 2 over 1. And of course, what I get is pi. You can check yourself easily. Just distribute. 1/2 times x is 1/2 x. 1/2 times pi is pi over 2. So we've done this correctly. Okay, we'll focus on graphing that. What's the basic starting shape? This is regular cosine, so that's the vase. The amplitude is 2. The period, let's see, that's 2 pi divided by the b number. Dividing by 1/2, same thing as multiplying by 2. So of course I'm going to get 4 pi for the period. We do have a phase shift this time. Remember, the c is the opposite of what you see. I see a pi in there, but obviously that means the phase shift is negative pi, meaning pi to the left. I didn't write down the midline because it didn't change. The midline is just at its normal spot along the x-axis. Okay, let's write down our x-coordinates of the 5 key points before the phase shift. We always start at 0, we end at the period, cut it in half, cut it in half. This is a very easy one. I'm counting by pi's, so of course this would be 3 pi here. Now, we're going to do several things if you read the directions there. We're going to start by graphing this cosine function. We'll make it dashed. We'll do it without the phase shift first. Then we'll do it with the phase shift. Then we can put on our final secant function. As always, we need to add our scale onto the picture. On the y-axis, I'll have to go up to 2 and down to -2. Remember, my midline is just right there along the x-axis. Okay, I think we can mark on our 5 key points. Again, we're ignoring the phase shift for the moment. The cosine function starts at the high, which would be 2 above the midline, then middle, low, middle, and high. I'll draw on my basic shape. So there's my basic vase shape. Then I need to take that, and I need to take into account the phase shift. The phase shift is negative pi, meaning pi to the left. Now, this is a relatively nice phase shift because I'm already counting by pi's. I think the only scaling I would need to add is right here with negative pi. I'm now going to take each of the previous 5 key points and shift it over to the left by pi. So that'll go there, this one will go to 0, 0, and so on. Shift all of those points 1 tick mark over to the left. Once again, draw in that nice vase shape. I'm making it dash. That's not my final answer, but I have enough now to easily draw on this secant function. Remember, the asymptotes go through the midline spots. So I've got one here. I'm looking at that purple picture as I focus on drawing in this secant function. So there's the location of asymptotes. The secant function, one period of it does have one downward u in the middle. It's got half an upward u on this side and half an upward u on this side. Now obviously there are complete u's there. I'm just trying to draw one period. I could make this thing go on in both directions easily if I wanted to. I'm just trying to draw one period here. Okay, I think the graph is finished. What about the equations of the asymptotes? Well, we've been writing x equals the first one, the nicest one, which here is 0, plus k times the distance in between. Looks like the distance between these asymptotes is 2 pi. We generally like to keep the pi at the end, so this would simplify to simply x equals 2k pi, k representing any integer. And then how about the range? Well, let's see. It looks like I have values from -infinity up to -2, and then it starts again at +2 and goes up to +infinity. And so here is the range of the function. We can always check our answer on the calculator. Let's see, I think I'll put in the corresponding cosine function first. I don't need to worry about using factored form here. And then in the next line, I'll put the actual secant function. I'm going to have to type that in 2 over cosine of that big parentheses. In other words, I've done 2 times 1 over cosine, which would be 2 over cosine. If we want to match what we did on the paper, we'll have to use approximately the same window. It seems like we went about from -pi on the left out to about 4 pi on the right. We were counting by pi. And the y going from -4 to 4, counting by ones, that looks about right. And here's the graph, and it matches. I have asymptotes at 0 and at 2 pi. You can see that downward U in the middle and those two portions of upper U's, at least to make one period, here on the left and on the right. And so we did it. Thanks for watching.